Okay, we are going to start with the introduction to chemical weed control. But I would want to explain the constraints or the problems of using herbicide technology under smallholder conditions. Now, a herbicide is a chemical used to control weeds. Normally, herbicides are selective. They can kill weeds, leaving the crops unharmed. For example, the use of atrazine in maize. But we also have non-selective herbicides which can kill everything, both weeds and crops. For example, glyphosate. Here I've got examples of herbicides in containers. So they are packaged in plastic containers. Worldwide, most of the herbicides are used in the northern part, in the northern hemisphere, in Europe, US, and also in Australia, India, South America, and in Africa. But the usage in Africa and some developing countries is on a low scale. Just looking at the use of herbicides, in 1896, the dominant chemical which was used to control weeds was copper sulfate, which was used to kill broad-leaved weeds in cereals. Later on in 1912, there was an attempt to use dilute sulfuric acid. But the real herbicides, as we know them today, came around 1944, probably just after the World War. So the first herbicide which was developed was 2,4-D, 2,4-dichlorophenoxyacetic acid. This is the herbicide which was widely used. But before that, these chemicals were used to kill vegetation during warfare so that soldiers could easily be seen. After the war, then these chemicals were developed into herbicides and they were used in agriculture. So 2,4-D kills broadleaf the weeds in wheat. Now in Zimbabwe, 2,4-D was introduced around the 1950s, as well as the trials in herbicides. So this technology is fairly recent in this country. By 1965, we had the weed research team established at Henderson Research Station, which was tasked to evaluate herbicides and to do weed control research. Around 1974, we now had glyphosate, which is a non-selective herbicide, being used to kill weeds, probably just before tillage or planting. Some of the herbicides are applied directly to the soil, which is pre-emergent herbicides. You can use a knapsack sprayer or a tractor boom sprayer to apply these herbicides. Now, just talking about the advantages of herbicide technology, number one, this technology can eliminate early crop weed competition, leading to higher yields. As opposed to mechanical methods or physical methods, this technology seems to be far more efficient. Of course, it depends on how this technology is handled. It can reduce time spent in weeding. Therefore, labor can be released to do other jobs. Remember, in November and January, especially in this country or in Southern Africa, we have what we call labor bottlenecks, where labor for planting competes with labor which is needed for early planted crops. And normally the early planted crops suffer because the farmers prefer to go on planting. They will be chasing the moisture. One of the disadvantages of mechanical methods is that under wet conditions, it becomes impossible to remove weeds. And chemical weed control becomes handy. So they can be used under wet conditions. Now with the conservation farming or agriculture, herbicides can allow reduced tillage to be done. And this can improve the timing of planting, which can increase crop yields. Well, if farmers are relieved from hand weeding tasks, probably their quality of life may improve in smallholder farming areas. Please note that women spend 75% of their time hoe weeding in the peak weeding period from December to February in Zimbabwe. This was reported by Chivinge in 1990. So if we have herbicide technology, we can relieve a lot of women from this task. Now, one of the advantages is that if we have a glyphosate, it can deal with the difficulty to control weeds, such as the cynodon-dactylon or Cyperus esculentus. If you are using mechanical methods, you are simply spreading these two weeds. Of course, there are disadvantages of using herbicide technology. Number one, these are poisons, they are toxic substances. Normally, when we talk about poisonous substances, we use LD50, which is the amount of poison which kills half of the organisms in a randomly chosen batch of named species. For example, with pesticides, we normally standardize LD50s with rats. So the measurement is in milligrams of poison per kg body weight. And these are some of the LD50s of our common herbicides. On top of the list, we've got paraquat with a purple triangle. It has a level of 100, which means it's very, very toxic. It's followed by 2,4-D 300. It's represented by a red triangle, which is also means dangerous poison. MCPA is around 700. It's represented by amber triangle on the labels, just to give a warning to the users. Glyphosate apparently is an LD50 of 4,320, which is a green triangle. It's just like a common salt, but there is information concerning 2,4-D, which is saying it's quite toxic. And I understand they've now changed the category. Probably it's now purple, I'm not sure. So you can have like acetaclone 900 EC, it's a herbicide. This is a very poisonous herbicide. It's represented by that orange triangle.
Sorry, Doc.
Yes.
The slides are not moving on my side. Are the slides moving?
Yeah, here they are moving. I don't know on others.
They are not moving from this side. I even raised a question, like a concern.
Okay, let us start afresh. So they are not moving.
No.
Yes, they are not.
Okay. Yeah, I'll have to start all over.